All right, so we are now in 5-4, product to sum and sum to product formulas. The product to sum formulas are going to be your favorites of these two. And these are on the back, down at the bottom. So we've got the sum to product and we've got the product to sum. You have to remember which one you're using, and it goes without saying. These sum and difference, and these we're multiplying. So are we, what are we given? And that's the formula box that we use. So looking at example 1, it says sine of 8x times sine of 2x. So, and sometimes it'll tell you express the given product as a sum. All right, so then we know we are going to do the product to sum. All right, so then sine 8x, sine 2x. Okay, this first one is always going to be your alpha. The second is always going to be your beta. Right? And you can make them whatever variable you want. It's just with respect to these, they're using alpha and beta. So sine and sine means we are using this one here. So that's going to be this top one. Okay. That is probably half the game right there, making sure you select the right formula. All right, now we just have to plug it in. So sine of 8x, sine of 2x is equal to 1/2 open bracket cosine 8x minus 2x, and then we have minus cosine alpha 8x plus beta 2x. Ugh. All right, so then we have 1/2 cosine of 6x minus cosine of 10x. There is nothing else that you can do here. I know it's tempting. You are going to want to subtract those, but you can't. So this is done. Nothing else left here. You can't distribute the 1/2. Just leave it as it is. This is it. Done, done, done. All right, now looking at example 2, it says express the given product as a sum or difference containing only sines or cosines. So product as a sum of sines or cosines means we're doing product to sum. We have cosine sine, so then you have to go through and look at them. This is sine sine, cosine cosine, sine cosine, cosine sine. So this is the one that I want to use. Let me see if I can, there we go. Hopefully that makes that a little bit smoother. All right, so I'm using this one here, which means that I need to identify my alpha and beta again. So the first one is always your alpha, the second one is always the beta, and since I'm using this one, it's going to be 1/2 open bracket sine open parentheses alpha plus beta. So I've got 17x over 2 plus x over 2 minus sine alpha is 17x over 2 minus the beta, which is going to be x over 2. Okay, now we just simplify. So I've got the 1/2 here, and I have sine 17x plus x is 18x. So we've got 18x over 2 minus sine of 17x minus x is 16x over 2. Okay, so now we need to clean this up, and we've got 1/2 sine of 9x minus sine of 8x. And this is the answer. There is nothing else you can do. This is it. We cannot combine those. We don't know what those are. It's not, these do not have a commutative property like we do with just the integers, okay? All right, so now we're looking at example 3. And example 3 says express the given sum or difference as a product of sines and or cosines. Now, context clue, this is addition, right? So addition, sum or difference. So we're starting with the sum or difference. So we're going to use this box here. And this is sine plus sine. So I've got sine plus sine right here. That's going to match what we have here. So this is the sine plus sine. Okay. Alpha always comes first. Beta always comes second. And so then we have 2 sine In the numerator of this one, we have alpha plus beta, so 2x plus 4x all over 2. And then we have times cosine alpha minus beta, so then that's going to be 2x minus 4x all over 2. Okay, clean this up, and that's going to give us 2 sine 2x plus 4x is 6x. 6x divided by 2 is 3x. 2x minus 4x is negative 2x, and then negative 2x divided by 2 is negative x. Okay, but we have a property that helps us with that cosine negative x. So this is not in its simplest form, because we have cosine of negative theta is equal to cosine theta. So if cosine of negative angle is equal to cosine positive angle, so this becomes 2 sine 3x cosine x, and then that would be the answer. Okay. All right, let's take a look at example 4. And for example 4, we've got express the given sum or difference as a product of sines and or cosines. So again, we're looking at that bottom left-hand corner, and this one has cosine and cosine. Addition, so we're doing this one here, cosine alpha plus cosine beta, and that is going to be this one here. Okay, so then alpha is 4x, beta is 8x, and now I just need to substitute this in. So I have 2 cosine alpha plus beta, so 4x plus 8x all over 2, times cosine alpha is 4x minus beta, which is 8x, all over 2. Okay, so clean this up. 4x plus 8x is 12x. 4x minus 8x is negative 4x. So then we've got 2 cosine 12x over 2 is 6x. Cosine negative 4x over 2 is negative 2x. But just like the last problem, we have that even odd identity. So cosine of a negative value is equal to cosine of the positive value. So this is the same as cosine of 2x. And then I just bring everything else down. I just don't know why my brain didn't want to do that. So then we've got 2 cosine of 6x, cosine of 2x, and this would be the answer. Okay, we are not done with verifying. I know, oh no, but it's not as bad as you might think. Personally, you could either start here, and remember cotangent is cosine over sine, right? So I'd have to figure out what's going on over here. I am not about all that. So I'm going to go ahead and look at this side because I have more to work with, which means I can hopefully deconstruct something. So I have sum or difference on that side. Let's see. Yeah, I'm going to do this one here, sine of 5x minus sine of beta. I'm going to do this one over the cosine minus, so I'm going to use these two. All right, so then, excuse me, my numerator is this one, and my denominator is this one. Okay, so this is my alpha, my beta for that first one, and that's my alpha, my beta in the second one. All right, so then we've got the numerator of this, of the left side, we have 2 sine, it's alpha minus beta, so 5x minus 3x, I'm going to just write everything down, all over 2, and then we've got cosine alpha plus beta, so 5x plus 3x all over 2, and then the whole thing, cosine 5x minus cosine 3x is this one, so I'm using this one. So that's negative 2 sine alpha plus beta, so that's going to be 5x plus 3x. all over 2, and then sine alpha minus beta, so 5x minus 3x all over 2. Okay, so now we need to clean this up. 5x minus 3x is 2x. 5x plus 3x is 8x. 8x and 2x. All right, so now let me clean this up. And I've got 2 sine 2x over x is going to give me just an x. Cosine 8x over 2 is 4x. And then I've got negative 2 sine of 8x over 2, so sine of 4x. And then sine of 2x over 2 is just an x. All right, so in the numerator and denominator, they both have a sine x. In the numerator and denominator, they both have a 2, but one's positive, one's negative. So that's going to give me just 1, and this one would be negative 1. So now I have positive cosine 4x all over negative sine of 4x. Cosine over sine is cotangent, so then this gives me cotangent of 4x, and that was a negative, so negative cotangent 4x will, hot diggity dog, and I just wrote that answer down here. So cosine over sine is cotangent because of the property, and then a positive divided by negative is negative, and then the 4x. And so this matches this one, and I have verified that identity. So see, not too bad. All right, I hope this helps, and then if you have any questions, just let me know.